Alright, so number one, we want to, it says use prime factors method to find the greatest common factor of 945 and 5145. Okay, so I'm going to show you again the two methods that showed up first, and then you can choose which one you like better. Alright, so first we're going to break both these numbers down into primes. So we're going to do the greatest common factor first. So we have 945 and we have 5145. Alright, so I'm breaking down the primes. This number is divisible by 5 because it ends in a 5, and it is a prime number. 5 goes into 9 once, leaving us with 4. Bring down the 4, so 44. 5 goes into 44 8 times. It gives us 40. Bring down the 5. 45 goes into there 9 times. And then, if our memory serves me correct, 17 times 17 is 189. Okay, not an easy one to note. I had to memorize all the perfect squares up to 25. So I do want to verify that though, just to be sure. I use this basic calculator. Let's just do 17 times 17. Make sure we get 189. That's 289. Okay, so that is not right. Okay, so if I add these digits up, I do know this is divisible by 3. Okay, so let's divide by 3. So I'm going to write a 3 here. 3 goes into 18 9 times, and 3 goes into 3 goes into 18 6 times. I'm looking at that 9. 3 goes into 18 6 times perfectly, and then 3 goes into 9 3 times. So 63. This is also divisible by 3. 3 goes into 6 2 times, and there once, and then we can divide by 3 again. 3 and 7. Okay. So here is our prime factorization. We have 3 3's, so I'm going to say 3 to the third, and then we have a 5, and then 7. So this is the first prime factorization. And then we're going to break 5145 into primes. Okay, so we know that this number is divisible by 5. 5 goes into 5 once, goes into 1 0, goes into 14 twice, bring down the 4, and 45 9 times. Alright, so this number is divisible by 3 if you add up the digits. So divide by 3, goes into 10 3 times to give us 9. We'll go into 12 4 times, and 9 3 times, so 343. 289, 18, okay. 4, this adds to 10, so not divisible by 3. 343, is that a perfect square? I know 17, 18, it's 324. It's not a perfect square. I don't believe that number's prime. So let me see. Not even 2, 3, 4, 5, 6. Maybe it's divisible by 7. I have to check. Let's see. I'm going to use this little calculator. I guess I closed it up. I minimized it. Let's verify we've made no mistakes first. So let's say 5, 1, 4, 5. We're going to divide that by 5. Alright, so we get 1029. We divided that by 3. 343. Has to be 10. I don't think that's prime. 2, 3, 4, 5, 6. Let's divide it by 7. 7 doesn't have a rule. Divide by 7. Let's see. Yeah. Divide by 7 gives us 49. There's no divisibility rule for 7. You just have to try some numbers. That's not a normal number that I'm used to seeing, but I do recall seeing it before. And then 49 can be broken down to 7 times 7. Okay. So if you recall those divisibility rules from 5.1, use those to kind of help you break it down. Okay, so the prime factorization will be 3 times 5, because we got 3 and 5, and then we have 7 to the third. 7 to the third power. Okay. Once you have the prime factorization, the greatest common factor, it says list the factors that they have in common. So they have 3 in common, they have 5 in common, they have 7 in common. Okay, I'm going to write down 3, 5, and 7, only because they're in both numbers. And then you take the smallest exponent. So out of the 3's, the smallest one will be this one, has an exponent of a 1, understood. Okay, so just leave the 3. Out of the 5's, they both have 1, so they're both the least. And then out of 7's, that has a 3, but this has a 1. So it's weird that the greatest wants the smallest exponent, but that's what they want. And if you multiply this 3, let's do 5 times 7 is 35. 35 times 3 is 105. So this is your greatest common factor. And then the least common multiple comes from the same numbers. Least common multiple, put an F for factor, least common multiple. Least common multiple will take all the factors. So 3, 5, 7, that's the only numbers that appear. So you start out with those numbers, 3, 5, and 7. And then you take the largest exponent. So out of the 3's, the largest one is the third power. 5's is just 1. And then 7, you would take the third power. So then you would multiply all this to get your least common multiple. And again, it's weird because the least wants the biggest one. So that opposite scenario kind of helped me understand this. So I'm going to multiply all of that out. So we're going to do 3 3's, a 5, and 3 7's. So 3, 3, 3, and then 5, and then 7, 7, 7. Okay. Let me see what I did here because that don't look right. 3 times 3 times 3 times 5 times 7 times 7 times 7. Okay. So I'm looking up here. We have 3 3's, 1 5, and 3 7's. So 46,305. Okay. That will be our least common multiple. Alright, so on the next example, hopefully we'll have some smaller numbers. I'll do the second method so you can see how that works. These are pretty big numbers, so it might take a while to do that second method. So 105, greatest common factor, and then oh, it didn't want us to find the least common multiple. Okay, well that's fine. Let's go ahead and do number 2. It also wants to find the greatest common factor. It says by dividing primes. Okay, so that's the one we're going to use that method on. So 150 and 250. Now it says dividing primes, but I don't think it really matters. I think just as long as it's a factor. So I'm going to pick the biggest thing. Like you might notice right away that you can divide this by 10. So let's divide by 10. Doesn't have to be a prime. Divide by 10, that gives you 15. And divide by 10, that gives you 25. Alright. So from there, we can divide both of these by 5, because you'll get there faster if you can find a bigger number. Divide by 5, you get 3, and you get 5. So from there, we can't divide anything else, so we just multiply 10 times 5, and that gives you 50. Okay, so you find factors that are common, divide them, and then we get there in 2 steps. This is going to be faster than the prime factorization because it does take time, but it will be beneficial to learn both if you can. But 50 would be what we're looking for here.